Hello, in this video we're going to look at labs 10, 11, and 12. We're going to start with lab 10. They're all kind of similar, so we'll do a demo first. So 10 is binary search trees. 11 is same questions but with linked list. 11 is same questions but with hash table. Okay, let's start with question number 10. So for each one of these, you want to copy. The one question was to come and see me. The second question is copying into your account the stuff from class. Okay. Okay, so just to get started, in case you haven't gotten started yet, you would go into the directory where you're supposed to be keeping this information. So you have a homework, lab 10, you go into lab 10 and copy from the class information. The files that you're going to need for the BST, so simple BST, you're going to call it simple bst2.c, but then you also need to copy the other files that are needed. So bst.star, and you also need words.star. Words has words structure and helper functions, and then you have the binary search tree stuff. So we go into simple BST2, and what was it supposed to be doing? Let's just check it out. Let's run it. So this is simple BST2, and this takes either standard input or a file. I'll give it lab10.txt. Okay, and what it does here is it prints the word with the maximal count. The simple BST from class printed all the counts. This is just printing the word with the most. Okay, so the advice there was to take simple, which is what I've done here. Take simple, and instead of printing the whole binary search tree, that's what's here, we want to find the largest in the binary search tree, which requires looking at the whole binary search tree. So you need to go to your how do you look at the entire binary search tree. That's something that should be on your list of what's the basic idea of how to do that. And the basic idea of how to do that is, so you have something called traverse. You're going to give it a binary search tree. You're going to need to traverse the left. You need to traverse the right. And you need to do something with the data that I actually have right here. And that will all stop if you ever get to a null. So this is your basic outline for traversing a binary search tree. If you're null, you don't do anything. Otherwise, you go left, you go right, and you do something. This is supposed to be data. Okay, for the example of finding the largest, we want to, find the largest. So we could return here bst node star. Instead of calling it traverse, we could call it largest BST. then we would be, instead of calling traverse here, largest BST, largest BST, and then we would want to save that value. Okay, so we have 2 pointers. The largest, what this is supposed to do is get the largest on the left-hand side, largest on the right-hand side, and then we also have root data count. We're supposed to be looking at the counts on this one. Okay, so then we need a bunch of if logic to handle root data count P1, data count P2, data count, and also P1 and P2 could be null. Okay, so the basic idea is you traverse the tree. That should be easy. You go left, you go right, you stop when you're null, you do something with yourself. For this particular case, it's a little bit of a messy if test. All right, there's your hint for that one. Let's take a look at number 3, lookup. Asks for a word to look up and prints out the count. So that's actually easier than number 2. Number 3. Okay, convert the word. So let me go back to the one from class. Okay, so for number 3, we don't want to print all this. Number 3, we don't want to print all that. Instead, we just want to ask for a word. What does it say to do? And get a word from them. And then I'm going to do a lookup BST with the root and with S, and then I need to do something with that. So that's going to give back a BST node pointer, and then I would do something with P. It could be null, could not be null. If it's not null, I can do printf. Let's see, or I could do print word, I think. P data. Something like this. There might be some errors there. But that's the basic idea. So you're going to ask for them to type a word. You type something, you look it up. If you get a null value back, you better not try to do p arrow data. If you don't get a null value back, then you print. The text here suggests to also convert everything to lowercase. Okay, so you add a loop here, loop over s, and convert to lowercase. So inside of, you may have a loop with I going from 0 to whatever, si equals to lower si. So inside of an appropriate loop. Okay, that's number 3. Number 4. Okay. So there's a hint here. We want to do the counts. So we want to traverse the tree again. This is another tree traversal. We should go back to my thing with tree traversal notes. Let's see, this was in here. So I took some notes on a function largest. So now we want to do a function counts. So instead of largest everywhere, I want to like do counts. Probably don't need to return anything here. And do something with root data. Alright, so this is my generic tree traversal going through everything. Now I want to do counts. I'm either going to have a global variable or a parameter passed in. Let's say that I have a parameter passed in int star counts. Or I'll call it int counts. Okay, square brackets, and let's say that somewhere in main I had done a counts array. Here's we'll do 256 and set them all to 0. Okay, so that would have been done ahead of time, and then somewhere inside of main we're doing counts, root, and counts. Alright, so in our counts we're going to do a tree traversal. We stop when we're null, we go left, we go right, and then we want to do something with our own data, and what we're supposed to do is check the first letter. So the first letter here is root data. That's a word type, so the actual word is W, bracket 0. Okay, so that's the actual first letter. And what I want to do is increase the count for that letter. I have counts. And since I have made an array of 256, I can just use that letter as an index into my array. And that would be that. Okay, so that's, I don't have to do any arithmetic about letters and subtracting off A or anything like that. I can just do the count for every character, not just for the letters. Okay, that would be number, whatever number we're on, 4. Okay, number 4. And when you're testing this, let's just go back to looking at what the test would look like. Simple BSD. All of these take files. Either it has a file name or you type, so it's easier just to give it a file name. Okay, so I give it a file name, and it tells me that there were 57 words that started with T in that file. You probably want to make a small file that has just a little bit of stuff. The word is the. Okay, so that's small enough that I know what counts I should get. Okay, I have 2 that start with T, 1 that starts with W, and 1 that starts with I. That's correct. The point of doing a small test for you is probably you don't get the right answer. You get some mysterious mess, or you get a segmentation fault or something. Rather than just scratching your head, something you can do is make a small file, run it, and see what it looks like. If it still looks like a mess, then you know you really have a problem, and start looking at your code or doing your other debugging techniques. All right, number 5, doing the count based off the second letter. Okay, so we were over here. If we want to look at the second letter, that's a bracket 1 instead of bracket 0. You also might want to worry about single letter words. What happens if this word here is just A? So note if W is just A, then what is W bracket 0? That's A. And W bracket 1 is 0, the null character. So we write that like this, or it actually is 0. Okay, so you can go to 1 as the index for the second character. That'll be okay. If you happen to have a one-letter word, then you'll be getting a 0 for that, and that's actually okay as well. We'll just get a count for the 0th, for things where the second character is the null character. That's okay. All right, that would be it for number 5. And number 6 is not graded, so I'm not going to talk to you about it. Let's look at lab 11. So lab 11 is going to be the same thing, but now with a linked list. Okay, number 2, copy your stuff in, find largest. You're going to have to do a loop through a linked list. So your loop through a linked list. So your loop through a linked list, you have to remember, is basically this is something you just have to memorize for whatever your variable type is. I think we called it list node t, p equals head, list node p, let's see, well it's, so start at head, it's not null, p equal to p next, and then inside of the loop, do something with p data. Okay, so that's your basic loop that you're gonna, that's the main thing, and then you have to do something with the data. The thing we're looking for is finding a largest. Finding a largest, you have, let's say we want to remember the largest node is, we'll start off being the head. So if we want to find the largest, we want to compare p data count against largest node data count. Okay, so what if the one I'm looking at now in my loop is bigger than the largest that I had? Then the largest should be now p. Okay, so that's your basic outline. How does it look in my code? There's my loop. This node t, p equals head, p not equal to null, p equals p next. I have a variable called max, starts off being head. If the count when I'm going through my loop is bigger than the max, set that to be the max. The word with the maximum count, and then I have a print word function, so I just go ahead and use that. I'm going to pause, you can pause there. Alright, number 3 is the same as for lab 10. Now you're just going to go into your main function, copy the original simple list into simple list 3. Instead of printing everything, do your printf scanf to ask for a word to look up. Alright, simple 4 is going to be another Take your answer for number 2 where you loop through, but now you're going to look at the counts inside of the loop. And looking at the counts will be very much like from the binary search tree. So in the binary search tree case, when we were looking at the counts, okay, we had root data. This was where we do our looking at ourselves in the binary search tree case. In the linked list case, this is our linked list for the first problem. The thing we memorize is this. Start ahead, keep going, and then inside of here, instead of looking at the count, we want to look at P data. Now we want to look at the word W bracket 0. Okay, so that's the thing we want to look at instead of doing this count business when we're doing number 4 and number 5. Right, number 4 we're looking at the first letter, number 5 we're looking at the second letter. All right, that's it for this one. Lab 12 is now with a hash table, which comes after linked list because our hash table is made out of linked lists. So basically, number 3 is going to be the same. We just put in whatever you had for number 3 on the other ones, you put that part into the simple hash and use the lookup hash. All right, number 2, 3, and 4, we have to do a traversal of a hash table. So you need to have your traversal of a hash table. So your basic traversal of a hash table is you have some index. 0 goes up to hash table size or something, however we're storing that. And then you have some array somewhere. T hash table size, it's going to be some array T. So when we look at T bracket I, in our case, we have linked lists. So then we'll do the linked list business. For list node T star P equals T bracket I. Okay, so if we're storing a linked list there, it might have been defined like this. So this, going through a linked hash table, you sort of have 2 loops. You go through the table, and then if you have a list at each item in the table, then you have to do the list business. And then inside of here, we'll do whatever we need to do. So for number 2, we're doing the largest business. So we're going to keep some sort of max node, and then we're looking at P data count. If that's bigger than max data count, then now max should be P, or if we don't have anything for max. So either way. And it's important to put this one first, because if max is null, you don't want to do this. That would be a segmentation fault. If max is null, you cannot do this. If I put this check here first, if max is null, the definition of C says it's not going to look at this because there's an OR. It doesn't need to. All right, that would be for the max, for the find largest. For number 4, instead of looking for the largest, we'd be looking at P data W bracket 0 and doing the stuff with the counts array. All right, and this isn't exactly what it will be in the code because we didn't define the table exactly like this. So we go and look at what I have for that. So lab12 equal to okay, so I actually have a variable called t that has inside of it size and something called table. So size is going to be the hash table size, the size of the array. And then we have t arrow table goes from 0 up to that. The rest of this is just what I had. If you want to pause, go ahead. And that is it for labs 10, 11, and 12. And the number 6 problems, that's a challenge. I haven't given you any hints, so good luck. The end.